below are 3 coordinate axes. In the middle is a function that is f prime of x, a derivative function. Your job is to sketch f of x on top and f double prime of x on the bottom. I'm looking for rough sketches only. However, I do want to see maximum and minimums and inflection points in appropriate places, that the functions are positive and negative appropriately, and that they have the correct concavity if possible. Assume f of 0 is 0. Okay, so this middle guy right here we're told is f prime, so we're going to use that. And up above we're supposed to graph f, and down below f double prime. So I'm going to call this guy f prime in black. All right, it's easier to graph the derivative than the antiderivative. So let's think about graphing f double prime first. So we'll do f double prime here in blue. Okay, so we're going to write some information that we get looking at f prime. I can see that f prime is, let's see, we've got some big positive values of f prime here, and then eventually, okay, scratch that. I was kind of going the wrong direction here. So let's try this again. We know that taking the derivative gives you information about whether a function is increasing or decreasing. So what I want to do in thinking about f double prime is think about the first derivative of f prime, because that's what f double prime is. So I need to think about tangent lines that are on this graph right here. So I'm going to indicate that the tangent lines here in the beginning are pretty steeply negative. And then, you know, they're still negative, but negatively sloped, I should say, but not as steep. And then here, still downhill, but pretty darn close to 0 slope. And then they begin to get steeper, negative, and then eventually bottom out at 0. And then they become finally positive and even more positive. And so I'm going to just make some notations here that say that we've got some pretty big negative slopes there, and then some negative but not very big. And then here, it's negative but pretty close to 0. And then negative, not too big, and then kind of big negatives, and then negative, not too big, and then finally 0. And then a positive but small, and then like positive getting bigger. So what we need to do is draw a graph that indicates these, that reflects these signs. So I always start with my 0 slope. So it looks like that's happening, 0 slope is happening right here around 2.4. So I know that when I graph f double prime, which is another derivative here, that at 2.4, the value of this f double prime will be 0. So at 2.4, the slope is 0. And then to the right of that point, we know that we have positive slopes and getting bigger, bigger, bigger. So we're just going to indicate positive slopes getting bigger, bigger. And then it's a little bit more complicated to the left. So let's just focus maybe on this part first. So we know that we have negative slopes not too big here, and then negative slopes bigger over there. So let's see if we can draw that. So negative, but not too big, but getting more and more negative until we get to some kind of magical spot, maybe right in here where that tangent line is as steeply downhill as it will be, which means that we're not going to get any lower than this point, at least not nearby. And we can see that the slopes are still negative, but getting closer and closer to 0. So at some point, it kind of turns around and heads back up. Not, let's draw that a little bit more nicely. So something like that. Doesn't actually ever get to 0, but gets pretty close, as we saw right around there is maybe the closest it will get to being 0. And then as we look a little bit further to the left, we've got some slightly more negative slopes and then some really negative slopes. So it seems like we're going to start heading back down that way. I'm not super concerned with the scale of this graph, just that we account for the positive stuff and the negative stuff. And I think we could say maybe a tiny bit more, and that's that wherever this graph that we're staring at is concave up, the graph below should be, let me think about this for a second. Okay, scratch that. Concavity has to do with 2 derivatives away from the original function, and 2 derivatives away from this function is f triple prime, which we're not asked to think about. So I think that's a reasonable sketch. Again, I have a lot of latitude as I grade these things, just looking for the main characteristics and not too much for the scale, like, you know, the y-axis numbers. Okay, so that's the derivative direction. Let's go back up to the top now and see if we can go the antiderivative direction. So the goal here is to graph just plain old f. All right, so we know, this might take a couple of shots, so if you're copying along, then use a pencil because we're going to erase some stuff. So we know that, let's see what color we can use here, green. We know that anytime f is decreasing, f prime is negative. And anytime f is increasing, f prime is positive. So I'm just going to look at the signs of f prime. Anytime f prime is negative, f was decreasing. And if f prime was positive, then f was increasing. So I'm going to label over here just the signs of the values, the y values that I'm looking at on this graph, the f prime values. So these are positive y values here, all positive, all positive, all positive, until we get to a 0, maybe just a little bit further to the right there. That is a 0 y value. And now we have some negative numbers, negative numbers, negative numbers. I'm going to put 2 negative signs there. That's the smallest negative number I will find. And then these are still negatives, even though the graph is increasing. I'm just looking at the signs. Signs are negative because this graph is below the x-axis at this point. And then we've got another 0. That's helpful. And then the slopes become, the y values become positives, which means that our original function f must have been increasing over there. So I'm going to draw a rough sketch, and then maybe we'll account for a little bit more in terms of concavity. So what I need is something that is flat at about negative 0.6, and maybe out here a little less than 4. So I'm looking at the places where the derivative is 0, those x-intercepts. And so we should be increasing wherever the derivative is positive, then decreasing, and then increasing again once we get past that spot. So rough sketch, again, if you're following along, use a pencil because this is going to be rougher than the final answer will be. So what did we say? We said it was going to be increasing until we get to about, negative 0.6. So increasing until we get about to negative 0.6, and then decreasing until we get to about 3.8. Decreasing until we get to 3.8. Don't worry if your graph doesn't hit the x-axis where mine does. We don't really know where it hits the x-axis if it does. And then it needs to be flat at 3.8. So actually I came in a little bit too abruptly because we know it's got to start increasing again. So why don't I maybe try to flatten this guy out a little bit earlier so that it's really flat at 3.8 and then increasing the rest of the way. So this is a fairly good sketch, but it only takes into account the increasing and decreasing nature of f. But I think we can get more out of this. I think we can really get a handle on the concavity. And the concavity kind of falls out by looking at the picture we've drawn. Like we can sort of see some points of inflection. Like it feels like something changed someplace in here, right? It was concave down and then it became concave up. Can we really identify where that happens? And the answer is yeah, we can. One of the things we saw in class was that anytime f prime is decreasing, the original function is concave down. So we'll write that. If f prime is decreasing, then f is concave down. We saw that in class. And then the inverse of this statement, if f prime is increasing, then f is concave up. So now we can look at the increasing, decreasing nature of the f prime graph. We say, oh, f prime is decreasing, decreasing, decreasing all the way until we get there. So that entire time, because f prime was decreasing, the original f must have been concave down. So let's see if our graph just happened to reflect that. So it's up here in purple. We wanted to be concave down all the way until right here, which was right around 2.4. So let's see how close we got. Let's see. So concave down, 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 and then someplace around here is where the concavity changes. I wasn't paying attention to that when I first drew it, and you can see I kind of changed my mind over here and decided I needed to begin flattening out earlier. So this would be a good time to update our sketch and account for the correct concavity. So let's try it one last time. I think this will be our final version. So we know we are decreasing until we get to negative 0.6, and we're going to be concave down that whole time. So negative 0.6 is around here. So decreasing, concave down, and then flat at the top. And then I said decreasing, I meant increasing, concave down the whole time. And then we're going to be decreasing and still concave down until we get to the 2.4. I'll just make a note here, 2.4. So we're going to be decreasing concave down until we get there. And what changes there is the concavity. We're still decreasing, but now we're going to be concave up, because on this part of the graph, f prime is positive, f prime is increasing, which means f must be concave up. So we're going to do our decreasing until about 3.9 and concave up. Let's try that. Decreasing to 3.9 and concave up. And at 3.9, we had a flat tangent line. And now we just crossed over that 0 right there, which means f prime all of a sudden is positive, so f is increasing and still concave up the rest of the way. So I think that's about as good as I can do for you. Really take your time as you think about these relationships between f and f prime and f double prime. You saw that I paused the video several times. I don't know if you saw. I'll let the cat out of the bag here. I paused the video several times while I was making it to really think things through. Did I just say something that was true, or did I say something that I didn't quite mean? Even after doing this for many years, I still have to really slow down to make sure I'm saying correct relationships, because things can get pretty tricky as you relate the graphs of f and f prime and f double prime.